Several potential issues exist with the proposed electrical setup. Firstly, overcurrent protection must be carefully considered. The 350 kcmil underground cable is rated for 300 amps. The two sets of 10 cables, at 90 amps each, total 180 amps. This discrepancy could lead to overcurrent situations and create safety hazards. Secondly, transfer switch sizing requires verification. The transfer switch might not be appropriately sized for the 150 amps main S-connects. The switch must be adequately rated to handle the total load of the panels it feeds. Thirdly, panel and sub-panel sizing needs careful evaluation. The original panels and sub-panels may lack the capacity to handle the increased load from the transfer switches. These components must be checked and verified for compatibility. Fourthly, voltage drop is a concern. The voltage drop on the 10 cables, influenced by distance and load, may be excessive. This could result in voltage fluctuations and potential damage to appliances. To address these issues, firstly, upgrade the underground cable to 400 kcmil. This cable is rated for 335 amps, or even consider 500 kcmil, which is rated for 380 amps, to ensure proper overcurrent protection. Secondly, verify the transfer switch rating to confirm compatibility with the 150 amps main S-connects. Thirdly, evaluate the existing panels and sub-panels to determine their capacity and confirm compatibility with the increased load. Fourthly, perform voltage drop calculations to ensure acceptable voltage levels at the load terminals. When dealing with electrical systems, several factors must be carefully considered to ensure safety and compliance with electrical codes. Cable ampacity is a critical parameter. Ampacity refers to the current carrying capacity of a conductor, typically expressed in amps. The National Electrical Code, NEC, provides tables, such as NEC Table 310.15b16, that list the ampacities of various conductors based on their size, insulation type, and installation conditions. It's important to select conductors with ampacities that meet or exceed the expected load current to prevent overheating and potential fire hazards. Overcurrent protection devices, such as circuit breakers and fuses, are essential components of electrical systems. They are designed to protect conductors and equipment from overloads and short circuits. Overcurrent protection devices must be selected with appropriate amp ratings to coordinate with the ampacity of the conductors they protect. The NEC specifies rules for overcurrent protection in Article 240, including requirements for sizing overcurrent devices and protecting conductors at their ampacity. Transfer switches are used to switch between different power sources, such as utility power and generator power. They are commonly used in backup power systems to provide a seamless transition during power outages. Transfer switches must be properly sized to handle the load current of the circuits they serve. They must also be rated for the voltage and frequency of the power sources they switch between. Voltage drop refers to the reduction in voltage that occurs along a conductor due to its impedance and the current flowing through it. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. The NEC recommends limiting voltage drop to 3% for branch circuits and 5% for feeders. Voltage drop can be calculated using Ohm's law and conductor resistance data. Several factors can influence the choice of wire size for a particular application. These factors include ampacity requirements, voltage drop considerations, and installation conditions. Larger wire sizes have lower resistance and can carry more current with less voltage drop. However, larger wires are also more expensive and may be more difficult to install. Installation conditions such as ambient temperature and conduit fill can also affect the ampacity of conductors. When working with electrical systems, it's essential to follow all applicable codes and standards. The NEC is the primary electrical code in the United States, and it provides detailed requirements for electrical installations. Local codes and regulations may also apply. It's also important to use qualified electricians and to obtain the necessary permits before starting any electrical work. Proper grounding is essential for electrical safety. Grounding provides a low impedance path for fault currents to return to the source, which helps to prevent electric shock hazards. The NEC specifies requirements for grounding in Article 250. These requirements include grounding electrode systems, equipment grounding conductors, and bonding. Grounding electrode systems typically consist of ground rods, ground plates, or underground water pipes. Equipment grounding conductors are used to connect the non-current carrying metal parts of electrical equipment to the grounding system. Bonding is the process of connecting different metal parts of the electrical system together to create a common ground potential. Surge protection devices, SPDs, are used to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power line disturbances. SPD diverts surge currents to ground, preventing them from damaging sensitive electronic equipment. SPD are typically installed at the service entrance and at branch circuits. The NEC provides requirements for surge protection in Article 285. Electrical panels, also known as load centers or distribution panels, are used to distribute electrical power to different circuits in a building. Electrical panels contain circuit breakers or fuses that protect each circuit from overloads and short circuits. Electrical panels must be properly sized to accommodate the expected load current of the circuits they serve. The NEC provides requirements for electrical panels in Article 408. Conductors must be properly identified and labeled to ensure safe and efficient operation of electrical systems. The NEC requires conductors to be identified by color coding or other means. For example, grounded conductors, neutral wires, must be white or gray, and equipment grounding conductors must be green or bare. Ungrounded conductors, hot wires, can be any color other than white, gray, or green. Electrical boxes are used to enclose and protect electrical connections. Electrical boxes must be properly sized to accommodate the number and size of conductors and devices they contain. The NEC provides requirements for electrical boxes in Article 314. Wiring methods refer to the types of wiring systems used to install electrical conductors. Common wiring methods include non-metallic sheath cable, NM cable, also known as Romex, metallic conduit, and electrical metallic tubing, ENT. Each wiring method has its own advantages and disadvantages, and the choice of wiring method depends on the application and local codes. The NEC provides requirements for wiring methods in Chapter 3. Electrical drawings, also known as electrical schematics or wiring diagrams, are used to represent electrical systems graphically. Electrical drawings show the connections between different electrical components and the wiring paths. Electrical drawings are essential for designing, installing, and troubleshooting electrical systems. Electrical testing and measurement are essential for ensuring the safety and proper operation of electrical systems. Common electrical tests include voltage measurements, current measurements, resistance measurements, and insulation resistance tests. Electrical testing equipment includes multimeters, clamp meters, and insulation testers. Arc flash is a dangerous electrical hazard that can occur when a short circuit or other fault causes a high-energy electrical discharge. Arc flash can cause severe burns, blindness, and even death. The NEC requires arc flash hazard assessments to be performed to identify potential arc flash hazards and to implement appropriate safety measures. These safety measures may include using personal protective equipment, PPE, such as arc-rated clothing and face shields, and implementing lockout/tagout procedures. Lockout/tagout is a safety procedure used to prevent accidental energization of electrical equipment during maintenance or repair. Lockout/tagout involves disconnecting the equipment from its power source and placing a lock and tag on the disconnect switch to prevent it from being turned on. Electrical safety training is essential for all workers who work with or around electrical equipment. Electrical safety training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. The Occupational Safety and Health Administration, OSHA, requires employers to provide electrical safety training to their employees. Electrical maintenance is essential for ensuring the continued safety and reliability of electrical systems. Electrical maintenance should include regular inspections, testing, and cleaning of electrical equipment. Electrical maintenance can help to identify and correct potential problems before they lead to failures or safety hazards. Energy efficiency is an important consideration in electrical system design and operation. Energy-efficient electrical equipment can reduce energy consumption and lower electricity bills. Energy-efficient lighting, motors, and transformers are available. Power factor correction can also improve energy efficiency by reducing the amount of reactive power in the electrical system. Renewable energy sources, such as solar power and wind power, can be used to generate electricity and reduce reliance on fossil fuels. Solar panels convert sunlight into electricity, and wind turbines convert wind energy into electricity. Renewable energy sources can be integrated into existing electrical systems to provide a clean and sustainable source of power. Smart grids are advanced electrical grids that use digital technology to improve the efficiency, reliability, and security of the power grid. Smart grids can monitor and control the flow of electricity in real time, allowing for more efficient use of resources. Smart grids can also integrate renewable energy sources and provide consumers with more information about their energy consumption. Electric vehicles (EVs) are becoming increasingly popular as a clean and sustainable mode of transportation. Electric vehicles are powered by batteries that can be recharged from the electrical grid. Electric vehicle charging stations are being installed in homes, workplaces, and public locations. The NEC provides requirements for electric vehicle charging equipment in Article 625. Consider consulting a qualified electrical engineer.